So in this video, I will continue to show you like guided practice on how to solve logarithm equation. So we stopped at number 19 in class. There was a typo error with number 19. You need to remove the 2. There was a 2 right here for the base. Yeah, that 2 need to be erased. So we're going to erase that 2. And now the base is not 2, but the base is 10. So now the thing that you need to know about this is whenever you have two logs, you need to combine them. So you need to condense to one log. So it will be one log, and now you're going to do multiply the inputs like this. That's what you learn from the properties of a log. That whenever there's two logs and there's addition, then you multiply the inputs together like that. Like I said, this is base 10. It's not written there. Equals 1. So we are going to actually multiply these out like this. S squared plus, so it's going to be log S squared plus 7x plus 10. If you use your box to do this, okay? I don't want to do it here. But if you go ahead and do x plus 2 and x plus 5, you get that, okay? Now, after you've written it like that, the next thing is to write it in exponential form. So this is how you write exponential form. S squared plus 7x plus 10 equals 10 to the power of 1. Remember, there's a 10 here that is not written. So that 10 goes there, okay? Now, we are going to continue with simplify this. So now the important thing to know is that whenever you come across an equation that has a square in it, that is a quadratic equation. So you are free to use 3 methods to do it. You can either do it by factoring, or you can do completing the square, or you can do quadratic formula. You can do formula, okay? All right, but before you get started with quadratic equation, you know you have to get the right side to be 0 always. So we're going to subtract 10 from both sides. So it will look like this. S squared plus 7x, this is going to cancel, equals 0. Equals 0. So if you look at this carefully, this is the easy factoring. Easy factoring. Take out the x, so it will be x plus 7 equals 0. And now we're ready to set each of them to 0. Either x equals 0 or x plus 7 equals 0, x equals 0, or subtract 7 from both sides, x equals -7. Now we have two answers, 0 and -7. Remember what we said in class, that you will always have to go back and check if those solutions will work or not, because log does not accept all kinds of input. Log does not like 0. Log does not like negative numbers. So this x equals 0. Let's check each of them. So we're going to check input. Let's check the first input. The first input is highlighted in yellow, so x plus 2. Let's check it. So we're going to do 0 plus 2, and the answer is 2. Because 2 is greater than 0, then 0 is acceptable. So 0 is valid. 0 is valid. 0 is an answer. Also, we're going to check the -7. So we're going to check. Well, let's check with the other one. 0 plus 5 works also. So 0 plus 5 is 5. So 5 is greater than 0. That checks. Okay, so we're not done. We're going to go check the -7 now. Let's check -7. All right, so let's plug it into the first one, the yellow one. So it'll be -7 plus 2. The answer is -5. That is not greater than 0. This is -5 is less than 0. So -7 does not work. We don't need to check on the other side anymore. It doesn't work for one of them, then we know it doesn't work. So the only answer that works is, so we didn't need to check for this. If we put -7 plus 5 will be -2. We cannot have log as a negative number. So out of these two answers that we got, the only one that works is s equals 0. So the final solution to this problem is s equals 0. Is the only one that works for both of them, okay? All right, I'll get you started with number 20, but I'm not going to finish it for you, okay? Because that's your job. All right, let's get started with number 20. You see a minus here? That's a minus. Highlight it. That's a minus right here. That means we're going to divide the inputs. So let's try to divide the input. It's going to look like this with one log. Log. This will be the numerator. This will be the numerator. And this will be the denominator. It's going to look like, I'm going to write it, s squared plus 7x plus 12 divided by x plus 4 equals 0. Okay? Now you say, what do we do with this? What you do with this is to convert it to exponent equation. Again, there's a 10 here that is not written. So we're going to just say that this stuff over here, s squared plus 7x plus 12 divided by x plus 4, we're going to say that equals to 10 to the power of 0. See, it's coming like 10 to the power of 0 equals that, okay? All right, now we have converted it to exponent. So the next thing is to make this one, this 10 to the power of 0 as 1. This is 1. 10 to the power of 0 is 1. And then copy this other one the way it is. And now we're going to cross multiply. Put 1 under here and then cross this way and cross this way. So we're going to say that s squared plus 7x plus 12 equals x plus 4. So this is a quadratic equation like we've been doing forever. We know how to do this. We subtract x from both sides, you know, like that. And then we subtract 4 from both sides as well, okay? And now you're going to end up with s squared plus 6x plus 8 equals 0. I will leave it for you to factor this. Actually, you can factor it and you're going to get 2 answers. Your job is to go ahead after you factor it, then you go check it to see if it works or not. I'll check that in class tomorrow that you actually finished it, okay? Here is another one right here. All right, these are 2 logs. There's a log here, there's another log here. You can always guess now. We're going to combine the logs as 1 log. This is a plus. This is a plus. That means we're going to multiply 3x times 4 equals 4. See what we just done there? We just multiplied these 2 inputs together because of the rule that say log A plus log B equals to log A times B, okay? All right. So now we're ready to get rid of the log by writing this in exponential notation. So we look like this. 3x times 4 is 12x. Let's write it out first. 3x times 4 equals 2 to the power of 4. Like we learned in class, this is 2 to the power of 4 equals this, okay? All right. Now what we're going to do is we're going to multiply 3x times 4 is 12. Okay, so 12x equals 16 because 2 to the power of 4 is 16. To get x by itself, you divide both sides by 12 and you get 16 over 12 will be 4 over 3. Now we're going to check to see if it works. The only log that has an input with a variable is the first one. If I plug in 3 times 4 over 3, and the answer will be 4 because 12 divided by 3 is 4, that is a number that is greater than 0, so that means it works. So our answer will be 4 over 3. All right? I'll get you started with number 22. I'll let you think about what you need to do after that, okay? There is a log, another log. There's a plus between them. We're going to multiply them and keep only 1 log. Like so, x minus 5, x plus 2 equals 3. And now we can get rid of the law by doing exponential notation. So x minus 5, x minus 2 equals 2 to the power of 3. Now you can do it just like number 19. Okay, maybe I'll lead you a little bit some more, just a little bitty. This is a plus right here. S squared plus 3x, because this is 2, and then this is plus 3x minus 10 equals 16. And then subtract 16 from both sides. S squared minus plus 3x minus 26 equals 0. So you can do 13 and 26 is 26 is 13 and 2. It seems to me that this cannot be factored. 2 and 13 does not give me 3. So this doesn't appear to be factorable. Let's just check one more time. Oh, this is minus. This is minus. And then this is minus 3x. Okay. And 16, 2 to the power of 3 is 8. Sorry, it'll be tired. So just checking. See, that's how you check yourself, really, whenever you're doing this kind of thing. I see it doesn't work. Now I think it works. So I can do 6 times 3 is 18. So I can factor it as x minus 6. X plus 3 equals 0. And then x equals 6 or x equals negative 3. And then you check it. Check. Let's just finish this so that you have some example that works. We check the argument. We check the input. So let's check with 6 first and then check later with negative 3. If I do 6 minus 5, that's greater than 0 because it's positive, it works. If I do 6 plus 2, that's greater than 0 because it's 8. That works. So 6 works. Let's try negative 3 with the first one. We're going to test it with this one. All right, let's try. Negative 3 minus 5 is negative 8 is less than 0, so it does not work. If it doesn't work for one, we don't need to test for the other one. So our final answer for this problem is 6 is the only answer that works. So now you have a full problem worked out for you from the beginning to the end that has quadratic equation in it, okay? You're going to have to try on your own. I would check 2 more for you over here. I'll get you started with it. I think you can do all of this stuff. Just setting up the quadratics. All right. I don't think I need to do any more for you so I don't take away your learning. All right. Try on your own for the rest of them. And then tomorrow we'll see if you have a question about any of them in class. Make sure to check the answer key I'm going to post tonight. I'll post it about 8 o'clock tonight or less. I'll see if I can do it if I leave school, and then you can check your answer over there. See you in class tomorrow. Make sure you do your homework.